So here's a rectangle, yes? How do I find its area? Length times width. Width, length, right? So area equals length times width. If I tell you that the width is 2, it would look like that, right? And if I tell you that the length equals 5, it would look like that, right? And what would the area be? Easy peasy lemon squeezy, yeah? Okay, what if it's a square? It's still length times width, but what's different now? Length equals width, right? So do I need 2 letters? How many letters do I need? 1. So I could say, instead of length times width, I could say L times L or W times W, right? Right? Would I ever write L times L or WW? No, what would I write instead? L squared or W squared, right? So if this is L, then that's L, L squared. If I say they're W and W, W squared. Agreed? Okay. If I give you the area of a square, this square is 4, how are you going to tell me what W and L are? You're going to square root. That's where the name comes from. Everybody with me? You would take the square, forgot the U, square root of the area equals the side length. Now, why was 4 an easy one? It's got a rational square root, right? Remember that from before spring break, how we talked about rational and irrational numbers? What if I told you that the square is 7? It's irrational, right? How would you tell me how long the sides are? You would still do the square root of 7, right? Can you do the square root of 7? No. What do we do instead? Where do we get that value? From your calculator. Is it a real value? No, why not? Because it's a decimal that goes forever, right? You can't actually tell me how long the sides of those squares are because there isn't an actual answer. Is everyone cool with that? Yeah? Okay, and this is what we are going to use, what we just learned to deal with this question. Okay? What to do when it's not rational. Everybody cool? All right. This symbol is asking me to find 2 equal factors. What do I mean? 2 equal factors of the number under, and I'm putting under in quotes, under the sign. So if I give you the square root of any number here, what do I use to show I am discussing any number? X. The square root of x means I need 2 equal factors of whatever that number is. And that number is what we call the radicand. And that's a new word that I'm going to be using, so I need you to know what I mean. Puberty hit all of a sudden. I need you to know what I mean. When I say radicand, I mean the number under that symbol. Everybody good? Okay. How would I find the volume of this prism? Length times width times height, right? LWH. What if it's a cube? Is it still LWH? Yeah, but they're all the same. So it would be LLL or WWW or H, H, H. Would I ever write any of those things? What would I write instead? I would write L cubed, W cubed. I know the screen just went blank. H cubed. Right? Now, you're intelligent young people. If the area of a cube, we use the square root. What do I do if I have the volume of a cube? I would take the cube root. How do I write that? Cube root. Now, this symbol looks different, doesn't it? What's different about it? It's got a little 3. When there was no number there, I was looking for how many factors? 2. When there's a 3 there, what am I looking for? I'm looking for, asking you to find 3 equal factors of the radicand. Now, if I told you that this cube's volume equaled 8, how long are the sides? 2, because 2 times 2 times 2 is 8. Easy peasy lemon squeezy. What if I told you its volume equaled 12? Could we do it? No, we couldn't. It would be irrational. But after today, you are going to know what we do with those. Everybody good? Now you will notice the only thing that changed was that little number, right? The small 3 is called the index. And that's another new word. The index can be any integer. I shouldn't say integer, but I'm going to for us. Any integer greater than or equal to 2. It can't be 1, right? Because it's asking me to find factors, yes? And you must have at least 2 things to multiply, correct? So, it's anything bigger than 2. If it's not there, it's a 2. Otherwise, it's whatever it is. Now, what if it was a 5? How many factors do I need to find? 5. What if it was a 12? 12. Everybody understand? It's easy. If there's nothing there, it's 2. Everybody good? All right. Now, got a bit of blank space down here. You guys don't have this part written on your page, do you? You do? Okay, we're going to do that in a sec. A perfect square, a perfect cube. This gets a little weird. At the beginning, today, a perfect square, a perfect cube is any number which has an integer root. So what do I mean by that? Square root of 4 is what? 2. 2 is an integer, so 4 is a perfect square. Everybody cool? Square root of 9 is what? 3. 3 is an integer, so it's a perfect square. Everybody good? Cube root of 8 is what? 2. It's an integer, perfect cube. Cube root of 27 is 3. 3 times 3 times 3, right? It's an integer, so that's a perfect cube. Is everybody cool with that? Now we can go a little bit further with this. But for our purposes, this makes me happy if you understand what I'm saying. But I want you to think about it. What would the square root of 1.44 be? Don't go to your calculator, just think about it for a sec. What is the square root of 144? 12. Does this look almost the same? What do you think it would be? 1.2. Everybody cool? So, Is 1.44 a perfect square? Technically, because it's got a rational square root. Everybody understand? But that's kind of really nitpicky. Okay? For our purposes, I'm happy if you just get that. Everybody good? All right. Now, see what this says. Read it. You can read it to yourself. I don't like reading to you. This isn't story time. But I would like you to actually write this out because of what I say here. We use these so much in higher level math, and you all have at least one more year of math in front of you. It would really behoove you to memorize these. Not just know them. I mean memorize them. But again, it's up to you. 0 to 400, I'm just going to write them. I'm going to write the squares up top. The squares and the roots on the bottom. 0, 0, 1, 1, 2, 4, 2, 3, 9, 4, 16, and keep going until you're up to 400. You already know what it's going to be. It's going to be 20. Damn it, I ran out of room. Then do the same thing with the cubes. You'll probably have to use your calculator to do the cubes, but that's okay. You guys do that. I'm going to use the washer. I'll be RB. Now we're going to use these right now to do what your calculator does for you. And then I'm going to show you how we're going to use these to find better answers. I assume everybody has the squares now at least, right? All right. So, estimating a square root. Now, everyone will say, oh, Myers, just use your calculator. Yeah, that's fine. But as is proven by many, many tests, it's not necessarily an ability to use a calculator that gets you the right answer. So, we're going to spend a moment dealing with this. The square root of 72. Is it a perfect square? No, because we just listed them all, right? 72 was not on that list, was it? What are the perfect squares that are on immediately to the left and the right of 72? There's 64, which is 8, right? And there's 81, which is 9. Everyone agree? Square root of 64 is 8. Square root of 81 is 9. Now, you're intelligent young people. The square root of 72 is between them, yes? So the square root of 72 must be between 8 and 9, yeah? What is it? Well, let's look. How far is it from 64 to 81? How many numbers are in there? 17, right? So this has 17 steps along the way, yeah? How far is it from 64 to 72? 8 steps. So I took 8 steps out of a possible 17, yes? Now, isn't 8 over 17 pretty darn close to what? To 8 over 16? And what's 8 over 16? 0.5. So 8.5 could be our guess. Now go to your calculator. What's the square root of 72? Square root 8.48. My calculator's not turning on, so screw it. From our calculator, we got 8.48. And we guessed it to be 8.5. Everybody with me? That's all you do. Now, you take 2 seconds before you start a problem, and you know you got to find a root in there. Well, you can figure out about what it is. Everybody with me? So 180. Is 180 perfect? No. What's immediately to the left of it? Root 169, which is 13. What's immediately to the right of it? Root 220, no, not 225. Root 196, and that's 14. That's in the middle, right? How far is this? Remember, we're just estimating. 27. How far is this? 11 out of 27, right? What's that close to? Isn't that pretty close to 10 out of 30? Which would be what? 1/3, which would be what? 0.3. 13.33. What's the calculator give you? Because 1/3 is really 0.33333333333333333. What? 13.4. We're guessing 13.3. Good enough to know if your answer is right at the end of all your work? I think so. What about 300? What's it between? What's immediately to the left of it? 17, right? 289, which is 17, and 324, which is 18. How far is this? 33. How far is this? 11. 11 over 33 is what fraction? 1/3, 17.33. Everybody cool? All right. Now, what do you think happens if I'm looking for cube roots? Same thing, except the gaps are bigger, right? So we would do the exact same thing. $45 is between 27 and 64, which is 4. This, just estimate, 30 to 65, right? So it's 35, and this is pretty close to 20, yeah? Agreed? So it's, what, 20 out of 35? It's about 2/3, yeah? So 3.67. Cool? What about this one? Right. 343, which is 7, and 512, which is 8. This is approximately what? 180? Are we happy with 180? Okay. And this is approximately 60, yeah? Well, 60 over 180 is 1/3, 7.33. And then you guys can do the last one, that's fine. Then I'm going to shut up because my lesson is, well, I'm not quite going to shut up. We're going to do something at the very bottom here. So you guys work on that one, and then I want to set something up down here. What's this guy between? Anybody want the magic pen? No? Sad. Right? So this is pretty much 90, yeah? 90. And this is pretty much 50, yeah? 50 over 90 is a little bit more than half, yeah? Right? So, 5.6. Good enough guess for me. Everybody cool? All right. So just down at the bottom here, because this will help you out. Remember we started this unit with exponents, yes? And then we did LCM and GCF. And we used exponents again, didn't we? And now we're doing square roots and cube roots, which are using exponents again, aren't we? Because 2 squared is 4. Everybody's with me, yeah? Exponents are all about multiplying, yes? Everyone cool? Okay. What is the square root of 100? 10. What is the square root of 36? Use that knowledge to tell me the square root of 3,600. What is the square root of 3,600 without using your calculator? 60. Why? Yep. What is the relationship between that, and that? 36 times 100 is 3,600, right? Everybody with me? Everyone cool? Okay. So what would you do if I wanted the square root of let's go with 1,296. What could you do without using your calculator? Looks weird, right? I haven't taught you how to do this. But notice, I was able to break this big number down, yes? So what if I told you this was the square root of 324 times 4? What would the square root of 1,296 be? 18 times what? 2. Square root of 4. Which would be what? What's 18 times 2? 36. Everybody picking up what I'm putting down? The big numbers can often be broken down. That's our next step, but we're not going to get to that today. Now, can we forget all of our other rules, do you think? If I wanted, and don't write this one down, you're going to practice this. if I wanted the square root of 16 over 9, what do you think that is? I haven't taught you how to do it. I want to see what you think it is. If I told you 16 over 9 squared, where would that 2 go? On both of them. It would be 16 squared over 9 squared, yes? So where do you think that square root sign goes? To both of them. It would be the square root of 16 over what? Square root of 9. What's the square root of 16? What's the square root of 9? 3. Everybody with me? I didn't teach you that. You figured that out yourself from your exponent rules, right? Your job for this next 2 pages, and of course you have another job to get ready for your quiz tomorrow. On this page, okay, I want you to do the work. If it's irrational...
You cannot make it into a fraction.
Oh, is this what I think it is?
Yep.
All right. You cannot, it will not give you a rational number, right? And we've talked about that. Square root of 7, can't do it, right? So what I want you to do on this page is see if you can figure out all these square roots, no calculator. Everybody cool? If it's irrational, all you got to do is write irrational. That's what you're going to do first. Then, on the next page, you're going to do the same thing, but the numbers are bigger. I'll allow you to use your calculator, but I don't want you using the square root button. No button. So you can use your calculator to break the numbers down like we did right here. Everybody cool? Are you going to be able to get them all? Maybe, maybe not. Does it matter? No, because this is the practice. Everybody good? Try these, and then remember this page? How we only did what was on the left? Now you're going to do the right. All right? When am I going to be talking about that? Tomorrow. When? After the quiz. The quiz doesn't have anything to do with today. Everybody cool? So, if you don't get 147 this side of the page done, that's what you do tomorrow after we write our quiz. Everybody good? And I'm giving you 30 minutes now to work on it. Yes. Now, I want to show you what I mean here so everybody can understand what I'm talking about. Does 27 have we'll start with the first one. Does 196 have a square root?
Yes.
It's right on our list. What is it?
14.
14. And there's a negative out in front, so this is negative 14. Everybody good? Does 27 have a square root? Is it on our list? No. So that means it's irrational, right? So what do I write here? Irrational. Everybody cool? Now, that square root is covering everything, yes? So what does that really mean? It's the square root of 9 over the square root of 100, which is 3 over 10. Is that rational? That's a fraction. Are we okay? So that is the square root of that. That's what I want you to do on this page. Everybody understand? Right. You want to finish it. Simple as possible. Right? This is not as simple as this. Right? If I told you, you owe me the square root of $324, or you owe me $18, which is simpler? Right. Understand? Everybody good? Okay. And, one sec, let's go to the next page where it's more complicated. I'll do the first three with you. Is 576 on our cube list? No. So what is it? Irrational. Is 1728 on our cube list? No, because our cube list ends at 1,000, yeah? So this is something we would have to try to break down, right? Right? How would you break down 1728? We just did a whole day of breaking numbers down. How would you break down 1728? You'd go even? Okay, so you would divide that by 2, right? So this is the square root of 800, no, that's a dummy head, 850, 864. Are either of them on our square root list? 2 isn't. 2 doesn't have a square root. So what could I got to break it down again, don't I? 2, what would you break down 864 with? 2 again. Two and 432, correct? Well, okay, so now I've got, instead of 2 times 2, I've got 4, right? Does 4 have a square root? Okay. 432, that's not on our square root list, is it? Everybody understand how to do it? Following what's going on? I'm going to make it easier for you. No. Do that. Keep going. So that's that one. You're going to break it down. What about this one? Cubed root of 27,000. Does that break down into something easy? 27 is on the list. Times what? 27 times 100 is 27. 27 times 1,000. Is that on the list? Yeah. So that's the cubed root of 27 times the cubed root of 1,000, right? What's the cubed root of 27? 3 from our list. What's the cubed root of 1,000? 10. What's 3 times 10? Everybody see how it works? Is that a rational number? So we're happy. Please notice, you saw right away that 27 was on the list, so you used 27. Everybody cool? Yeah? Okay. This is the page you're going to have trouble with, and that's okay. We'll be going over it tomorrow. This page you should be able to rock in about 5 seconds.